Hello everyone. So let's solve this question, transpose matrix. As you know, a transpose matrix is the one in which we just have to alter the rows into columns to obtain our result. So for example, here 2, 4, minus 1. So it has been converted into a column. Here 2, 4, minus 1 written downwards. Here next row, minus 10, 5, 11 is written again as column wise, minus 10, 5, and 11. Same with the case of the last row. So let's see how the intuition actually works when we will write it with the help of code. See this example. This is a given matrix, and this is the transpose matrix that we will obtain. So how does this approach actually works? So let's do a try run and see. First, what we'll do is we'll generally scan this entire matrix one by one and try to do the transpose. So for this element, as you can see, the transpose matrix position is the same. For this next element, 0, 1, you can see the transpose matrix element is here. And for this minus 1, it is here. Now, if you observe carefully, we can see a pattern. So on the first matrix, the row and column, if we change it to the transpose matrix, what generally happens is it's in the same position, just we have to reverse the column and row. See here, for example, like first this element 2 was in 0, 0, and now in transpose matrix it's also in 0, 0. We just have to reverse it. Now for this 4, it was in 0, 1. Now this 4 will go to 1, 0. 1, 0 is this place, so here. Now minus 1 was in 0, 2. It will now go to 2, 0. That is here. For the minus 10 next element, it was in 1, 0. So we'll just reverse it. Reverse the rows and columns value. That will become 0, 1. And it will go right here. Then next is 5. It's 1, 1, which will be again in 1, 1, even if we reverse it. 11 was in 1, 2. So if we reverse it, it will be in 2, 1. That is here. 18 was in 2, 0. Now for the transpose, it will be in 0, 2. That will be here. For our minus 7, it was in 2, 1. Next, it will be in 1, 2. That is here. And for 2, 2, it will be again same place. So we can see that we obtain our transpose matrix. It was just that easy. We just have to remember this thing. So let's check it out in our code. First, we'll define our raw length. That will be the size of matrix itself. Then our column length. Also, we'll take a vector container to store our transpose matrix. And since like it's the reverse, right? So for our rows, it will be column. So that's why I'm first for the sizing, I'm first assigning it as column and then row. Basically, I'm just interchanging the dimensions. We'll run a for loop till our row and a nested loop that will run for each element in that row. That is up to column. Then what we'll do it, we'll just reverse it, right? Just what we looked beforehand in this example. We are just reversing the rows and columns. So first will be here column, then row index. and then assign it the value that is in matrix, normally for row and column. And we will just return the transpose matrix. Oh, sorry, give it here.